In this lesson, you will factor trinomials that are in the form x squared plus bx plus c. So we just have a coefficient of 1. And you also solve equations when they're set equal to 0. We'll be able to solve them. So the first type that you are going to have is when you have a plus-plus situation. And so what we're going to do is we're going to, when b and c are both positive, we're going to look for factors of 20 that will add to 9. And you're always going to make this little, you're always going to make that little box where you have two factors to sum. Factor, sum. You're always looking for the factors of the last term to get the sum of the middle. Factors of the last, sum of the middle. So you could just guess and check in here and keep keep erasing as you go. Some of you are really good guess and checkers, so you're going to come up with it right away. You're going to say, hey, it's 5 and 4. Because 5 times 4 is 20 and 5 plus 4 is 9. Some of you it's going to take longer. You're going to have to figure out what are all the factors, 1 and 20, 2 and 10, 4 and 5, so on and so forth, and sum them up yourself. So it just takes some time and it takes some practice. So because this is a 5 and a 4, what you can do is you can put a parenthesis x plus 5, parenthesis x plus 4. These are the binomials that when multiplied together would give you x squared plus 9x plus 20. And you could actually use FOIL to check that, or you could use boxes to check that. This is the fastest way to solve. I will show you another way. You could say x squared plus 5x plus 4x plus 20, and then you could do factoring by grouping like you did yesterday, and you could pull an x out like this, and that would be x plus 5. You could pull a 4 out here, and that would be divide by 4. And so then you get x plus 5, and hey, ooh, look, I'm going to pull x plus 5 out because they both have an x plus 5, and look what's left behind, x plus 4. So you tell me which you'd rather do. Sum and product, and then that's your solution, or write it all out and do factoring by grouping. I think common sense tells us that this is faster. Let's try another example of using the shortcut. Here's my shortcut, ready? I'm going to look for a product of 24, it's the product of the last term, that gets you a sum of the middle, sum of 11. So use some guess and check here. It is 8 and 3, right guys? 8 plus 3 is 11, and 8 times 3 is 24. So you look at your letter, this is going to be D plus 8, D plus 3. When you have a sum and a sum, you're always going to have two binomials that look like this. They're going to be a plus plus whenever it's a sum. And you can use that as your shortcut. If you want to do the long way and do factoring by grouping, you go for it. You do it. But this is a lot faster doing the product than the sum. So you try the example in your notes. Now what happens when you have your b as a negative and your c as a positive? So this is a minus and this is a plus. I still start the same way. I'm looking for a product of 12 that would give me a sum of negative 8. Negative 8, because that's the b term. So now you're having to think about relationships with positive and negative integers. So factors, 1 and 12, 2 and 6, 3 and 4. These are all the factors of 12. To get a sum of negative 8, if I have negative factors, think about this, if I have negative factors, that would give me negative sums. See these three negative sums here? And here's the one that I need. A negative 2 times a negative 6 would give me a positive 12, and a negative 2 plus a negative 6 would give me a negative 8. So those are the terms I need. I have an x minus 2, and I have an x minus 6, and that's my binomial. I can use FOIL or boxes to check. If you want to do it the long way with factoring by grouping, go for it. But this is a much faster way. Let's check here. What product of a positive 28 would give you a sum of negative 11? Are you thinking here? Guess and check. It's going to be negative 7 and negative 4, right? Negative 7 times negative 4 is positive 28, and negative 7 plus negative 4 is negative 11. So I look at my letter and it's W, so it's W minus 7, W minus 4. Those are my two binomials. What do you notice when that middle term is negative? What do you notice about your binomials? Hey, it's always going to be a minus minus, isn't it? Every single time you're going to have a minus minus relationship. When that middle term is a minus, it's going to be a minus minus relationship on your binomials. All right, what happens then when I have a middle term positive and my product is negative? So I'm looking for a product of negative 15 that would give me a sum of 2. So when you think of products of negative 15, that's negative 15 and 1 and negative 1 and 15. That is negative 3 and 5 and negative 5 and 3. When you think of factors, one of them has to be negative to get a negative product. And what gives me a positive 2 sum is this one right here. When I have a negative 3 times a positive 5, and I add that negative 3 plus the positive 5, that would give me the relationship I need here. So I have x minus 3 times x plus 5. So one is negative, one is positive, and yes, it matters which is which. It matters which one is negative and which one is positive because that will change your sum. How about this example? I'm looking for a product of negative 48 that would give me a sum of a positive 13. So negative 48, they would give me a sum of a positive 13. When you think of things that would multiply to get 48, think of your factors. Use a little guess and check if you need to use some guess and check. I'm going to cheat a little bit here and look, and I get, well, it would help if I would write the right problem. I think it's 16 and 3. And so I need to have a positive 16 and a negative 3. I need to have a positive 16 and a negative 3. So I'm going to have y plus 16, y minus 3, and that's my result. When you have this last term as negative, you're going to notice that it's going to be a plus minus relationship. Like one is going to be a positive binomial, the other one's going to be a negative binomial. So try the example in your notes. What happens when they are both negative? So in this example, you're looking for a product of negative 18 that would give you a sum of negative 7. So factors of negative 18 and 1, negative 9 and 2, and negative 3 and 6. So which of these gives you a sum of negative 7? That's this one right here. So we're going to do negative 9 times 2, negative 9 plus 2, and in those situations I have both negative. So when you look at your binomials, it's x minus 9, x plus 2. That is an opposite relationship just like you had last time when the last term was negative. Here I have a sum of negative 24 that would give me a product of negative 2. So I'm looking for two factors of negative 24 that would give me a negative 2 difference. And that's going to be, let's see, I'm going to say 6 and 4. And one of them has to be negative, and I have to make sure it's the negative 6 because I need a sum of negative 2. So the bigger one has to be negative. So in my result, I have r minus 6 times r plus 4. You're going to see a plus minus relationship again when I have both terms negative. One's going to be positive, one's negative. All right, so you try the example in your notes. Now, what can we do to solve? The first thing we're going to do is set it equal to 0. So I subtract 27. And now I have x squared plus 6x minus 27 equals 0. I'm now going to factor. So I'm looking for two numbers that when multiplied together give me negative 27, but when added together give me a positive 6. So that is going to be 9 and 3, and my 9 is going to be positive, my 3 is going to be negative. So in this case, I'm going to write it out like this. I have x plus 9 times x minus 3 equals 0. Now that I have two binomials, I can separate them like we did on the last assignment. So I have x plus 9 equals 0, x minus 3 equals 0. I subtract 9, and I get x equals negative 9. I add 3, and I get x equals 3. Fat man bracket, go in order. Negative 9 is first, then 3. So this is a parabola that hits at negative 9 and 3. So that's why I have two solutions. Check the example in your notes. All right.